So in this video, we're solving AS Math paper 52 from the session November 2023. The first question here is, a competitor in a throwing event has 3 attempts to throw a ball as far as possible. The random variable x denotes the number of throws that exceed 30 meters. The distribution table for x is shown below. Given that the expected value is 1.1, we need to find the values for P and R. So we know that the probability sum adds up to 1, 0.4 plus 0.15 plus P plus R should be equal to 1. P plus R is equal to 0.45. And for the expected value, we have the formula for summation of x multiplied by P. So 1.1 is equal to 0 times 0.4 plus 1 times P plus 2 times R plus 3 times 0.15. This simplifies to 1.1 is equal to P plus 2R plus 0.45. P plus 2R is equal to 0.65. This is the second equation. Now when we solve these two simultaneously, we'll get the values for P and R. P comes out to be 0.25 and R comes out to be 0.2. In part B, we need to find the numerical value for variance of x. Variance has the formula summation of x squared times P minus square of the expected value zero multiplied by 0.4 plus 1 square multiplied by 0.25, which is the value for P, plus 2 squared multiplied by 0.25, which is the value for R, plus 3 squared multiplied by 0.15, minus 1.1 whole square. The answer comes out to be 1.19 for the variance. In question 2, George has a fair 5-sided spinner with the sides labeled 1 to 5. He spins and notes the number on the side on which the spinner lands. Find the probability that it takes fewer than 7 spins for George to obtain a 5. So this is a question on geometric distribution. And we want the probability for x less than 7. Let's draw a number line for this. If we need the probability for less than 7, this means we want less than equal to 6. Which can be obtained by subtracting 1 minus p x greater than 6. We can obtain this by 1 minus q power 6, and in this case, the value for q is 0.8. 1 minus 0.8 power 6. The probability for x less than 7 comes out to be 0.738. In part B, we're given that George spins the spinner 10 times. Find the probability that he obtains a 5 more than 4 times, but fewer than 8 times. So the number of trials are fixed now, which means that the variable is following a binomial distribution. Now we need more than 4 times, but fewer than 8 times. So five, 6, and 7 basically. Now the probability of success over here would be 0.2 and failure would be 0.8. So we'll find the values for 10C5, 10C6, and 10C7 terms. 10C5 would be 0.2 multiplied power 5 multiplied by 0.8 power 5 plus 10C6, 0.2 power 6 and 0.8 power 5 power 4, sorry, plus 10C7, 0.2 power 7 and 0.8 power 3. We'll add these 3 values to get the final answer. The answer is 0.0327. In question 3, a factory produces a certain type of electrical component. It is known that 15% are faulty. A random sample of 200 components is chosen. We need to use an approximation to find the probability that more than 40 of these are faulty. So since we're looking for faulty, our probability of success would be 0.15. The probability of failure over here would be 0.85. N has the value 200. And we're looking for the probability for x greater than 40. So for approximation, we'll find the mean through NP and the variance through NPQ. The value for mean is 30 and the value for variance should be 200 times 0.15 multiplied by 0.85. These are the two values for mean and variance. Now we'll apply the continuity correction on the given data that we need more than 40 of these components to be faulty. So the probability would be x greater than 40.5. Now we'll standardize the data. 40.5 minus 30 divided by the root of 25.5. The z value comes out to be 2.079. Probability for z greater than 2.079 would be equal to 1 minus the probability for less than 2.079. We have 1 minus 0.9812. The answer for this would be 0.0188. Question 4 is asking us for constructing a stem and leaf diagram for both the data sets. I have data values from 160 to 190. So I'll take 16, 17, 18, and 19 over here. I'll take aces on the left-hand side and jets on the right-hand side. So in aces, we have 166, 164, 168, 169. And the data should be in ascending order. So we'll write 164, 166, 168, 169. For the jets, I have 166 and 168. And then we move on to 170s. I have 171, 173, and 174. For jets, I have 170, 174 twice, and a 175. For 180 aces, I have a 180, 181, and two 182s. For the jets, I have two 181s, two 188s, and a 190. Now we need to construct a key for this. Now in this key 1, column 17, column 0, 171 for aces and 170 for jets. Now in part B, we need to find the median and interquartile range of the heights for aces. For median, we have the formula n plus 1 upon 2 for the position. So 11 values plus 1 upon 2 would be 6th position. Now over here, the 6th position is 173. Now this median has divided the data into 2 equal halves of 5 values each. Now out of these 5 values, the middle value would be the third value. And out of these 5 values, the middle value would also be the third value. The median is 173. The lower quartile is 168. Upper quartile is 181. So the interquartile range comes out to be 13. In part C, we need to comment on the spread of the heights of the aces with the spread of the heights of the jets. So for this question, we can either compare the interquartile range or the range of the data sets for both these data values. So aces have the lowest value of 164 and the highest value of 182. So aces have a range of 18 values from 164 to 182, and jets have a range of 166 to 190, which is 24 values. So we can conclude and comment that jets have a greater variety or a greater spread in height. Moving on to question 5. The height of the members of a club are normally distributed with mean 166. And the standard deviation of 10 centimeters. In the first part, we need to find the probability for a member to be less than 170 centimeters. So we'll standardize the data. The probability of Z less than 0.4 The answer for this would be 0.655. In part 2, we're given that 40% of the members have heights greater than h. And we need to find the value of h correct to 2 decimal places. So let's draw a diagram to understand this. %40 members have a height greater than h, which means h has to be to the right-hand side of the mean. If 40% are greater than the height h, then 60% should be less than the height h. So the probability for x less than 0.6 is, the probability for x less than h is 0.6. The z value should be 0.253. Now we'll use the standardization formula to find the value of h. So 0.253 is equal to h minus 166 upon 10. H is equal to 168.53. Moving on to question 5, part B, we're given that the random variable x has a mean of mu and a standard deviation. We're given that the standard deviation is 2/3 of the mean. We need to find the probability that a randomly chosen value of x is positive. For x to be positive, it should be greater than 0. The standardization formula would be 0 minus mu upon standard deviation. So 0 minus mu would be minus mu upon 2/3 of mu, which is the value for the standard deviation. And the probability for z greater than, when we divide minus mu with 2/3 mu, we get 1.5 minus 1.5. So to find the probability of z greater than minus 1.5, we'll find the probability of z less than positive 1.5. The answer comes out to be 0.933. Now in question 6, we're given 2 bags of marbles where bag X contains 7 red and 3 blue. And bag Y contains 4 red and 1 blue. Freddy chooses one of the bags at random. A marble is removed at random from the bag and not replaced. A new red marble is now added to each bag. A second marble is then removed at random from the same bag the first marble had been removed from. We need to draw a tree diagram to represent this information, showing the probability on each of the branches. Okay. So the probability for choosing either bag X or bag Y is random. So it's equals on 0.5. Now bag X has 7 out of 10 red marbles and 3 out of 10 blue marbles. Bag Y has 4 out of 5 red marbles and 1 out of 5 blue marbles. Now moving on to the last portion of this question. Once we have removed a marble, a new red marble is added to each bag. So if we're removing the red marble, this becomes 6 upon 9, but then we add a new red marble, so this becomes 7 over 10. So there's no change in this case, and blue remains the same. If we remove the blue marble in the first trial and add another red marble, then we'll have 8 out of 10 red and 2 out of 10 blue. Now coming to bag Y, if we remove one red and add another red, we'll get the same probability. But if we remove one blue and add another red, we'll have 0 blue and 5 out of 5 red. This completes our tree diagram for question 6, part A. In part B, we need to find the probability that both the marbles removed from the bag are the same color. So this means probability of both blues plus probability of both the reds. For X and Y, both of them, so we'll have 7 over 10 multiplied by 7 over 10 plus 3 over 10 multiplied by 3 over 10, and both of these multiplied by 1 over 2. These are the two cases for bag X for both red, red and blue, blue. And then we have two cases from bag Y as well. 4 upon 5 multiplied by 4 upon 5. And there is no second case for bag Y because there's only one blue marble in it. When we add these three, we'll get the answer as 0.595. Now in part C, we need to find that both the colors are not the same and bag Y is chosen. So bag Y, given that different colors. We have the probability for same colors, which is 0.595. So different colors would be 1 minus 0.595. Now different colors with bag Y would be 1 upon 2, 4 upon 5, 1 upon 5, and 1 upon 2, 1 upon 5 into 5 upon 5. So red, blue, and blue, red. The answer comes out to be 9 upon 50 divided by 81 upon 200. When simplified, this gives us 4 upon 9 or 0.444. Now in question number 7a, we need to find a different number of arrangements for these 9 letters in which no consonant is next to each other. So we have D, M, N, D, R as the consonants. We have 5 consonants and 4 vowels. So we'll place the 4 vowels over here. And the 5 consonants can come in these spaces. 5 factorial for the 5 consonants and multiplied by 4 factorial for the vowels. And we'll divide this by 2 factorial because we have 2 D's and another 2 factorial because we have 2 A's. The answer for this comes out to be 720. In part B, we need to find the number of arrangements of the 9 letters in which there is an A at each end and the D's are not together. Let's fix both the A's. Now we have 5 letters and 2 D's. The D's can come in these positions. So we have 6 places for the first D and 5 places for the second D divided by 2 factorial for repetition. multiplied by 5 factorial for the remaining 5 letters. The answer comes out to be 1800. For part C, we need to select 4 letters randomly from the 9 letters. And we need to find the probability that this selection contains at least one D and exactly one A. We have 2 A's, 2 D's, and 5 random letters. These are the 2 possible cases. 1 A, 1 D, and 2 random letters, or 1 A, 2 D, and 1 random letter. So for A, we have 2C1. For D, we have 2C1 as well. And for the random letter, we have 5C2 in the first case. For the second case, we have 2C1 for A, 2C2 for D, and 5C1 for the last random letter. We'll add these two. So the answer comes out to be 50 possible selections. Now we need to find the probability for this. So we'll divide 50 by the random selection of 4 letters, which would be 9C4 in this case. The answer would be 50 over 126. Can also be simplified to 25 upon 63 as the final answer. It's the end of this exam.